Hello, how are you? Yeah, I hope you're doing okay. All right, so let's talk about the lab for today. If you can access your Canvas and download lab 6. Okay. All right. So let me share screen. Let me zoom in real quick too. And I need a caption. Hold on a second. Okay. So today we are going to do lab 6, which is going to be Numba and Pypy. You can run, I believe the first exercise, you should be able to also run that in Tani or your IDE if you have the package linked. But I wrote the instruction for you to use Linux or Ubuntu virtual machine. Now the only challenge on the IDE side, I think just gotta make sure that you are able to extract PyPy. So there's some information about that and we'll touch on that. The lab is not too long today. We are going to do some sort algorithm. And so to start, we can boot our Linux virtual machine, which is Ubuntu, if you have that. And so in the bubble sort, you might have seen this in another programming course, but bubble sort mainly is a way that we can implement comparison in our algorithm. And if the value is lower, because we are sorting ascending order, that means that we're going to go from low to high. We would then be able to move the number to the front. Now, because when we're moving the number, we have to make a memory location so we can put it in temp, and then we would do a swap. And I call this a triangular swap. So if I need to take 27 and move it before 33, I can't just swap it from here to here. What I need to do is I need to take it from this location in the container and I need to put it in a temporary. Then I would do the move for the 33 to that space and then take the temporary location where 27 is at and I would place it in front of the 33. So when we do this, we would need to make sure that we can either use a variable or a location in memory for our container to be able to move. So bubble sort, as it mentioned here, that is not suitable for large data sets. This would work well when you have a smaller group of values. And in the worst case scenario for O of n, we would see that because sometimes you would see that it's written with the nested linear operation. So you would have n to the second power. And the n would represent the number of input. That will be the number of values that you are sorting. So in this case, in this example, we would see 5. So for the smaller group of numbers, it would work really well with bubble sort. Now, because it's doing the comparison 2 elements at a time, right, you would have to bubble out. So meaning that we would do the 2 elements, we would move the one that's lower to the temporary, and then from the temporary, we'll move it to the front location for that element. So then this is just to illustrate the mechanical part of the bubble sort, right? So at the end, when you finish with the sort, you would have the ascending order from low to high. Okay. And so it would continue to do the comparison as it go down the line for your group of elements. And so it would pair them up, compare, and then move, or sometime in the case where if it's already in order, it would keep it the same, but it still need to do the comparison. So the way that we would implement the algorithm is to look at how we would swap one item in the array if that item is lower, okay? And so we would set the flag to make sure that it is swapped. Now to implement Numba, because we mentioned that Numba can improve the performance on the Python side, you need to really install that, okay? Now, first, what I'm going to do is I'm going to show you on the IDE, which is Tawny that I'm using. And then you can run the first one on here. And then we're going to look at the Linux side, which is what is written in the lab. So as we're using Numba, just like the assignments that we dealt with this week, you are going to make sure that Numba is installed. And then we just search for the package and click install. Okay, so you can run this one on your IDE or Linux. Now, in this program, you have a function called bubble sort. Okay, and what we're going to do is we are going to treat X as the value that we need to sort. N, the big N right here, is indicating the number of elements or the number of input that you have to sort. So it will be, for the X would be our elements in the container. Now you can use the array and you can use NumPy to be able to generate and create the array container. That would also be another way. So technically what we can do is we can start out with an array, right? The traditional way, and then compare 2 elements at a time. Now, as we go inside the container and access each of the element, you have to implement a loop. Okay. So what we're going to do is we are going to have the length of X. And we're going to go to the end of that array using the length method. And N is simply our input value. So for our loop, the outer loop, we are going to have a for loop. And this is the for range. So what we're going to do is we're going to access each of the element using this loop. Okay. As we need to look at the index and the next index. So your index is going to be I for the inner loop. Okay. So in the inner loop, you're also going to have a for range, and we're going to access the index, which is I. Okay. Then our variable CR is going to store the value for each of the index. And we want to check to see if that value is greater than the next value, which is index plus 1. So if I start out with 0, which is the index, right? I want to check with 0 plus 1, which is the next index. So with that, we need to implement an if statement to do the comparison. So simply I'm checking the value for the current element against the next value in the next element. And so if it is greater, I'm going to put it into a temporary location called temp, which is a variable. And then I want to then move by doing the reassignment. So as I take the larger value and put it into the temporary location, I want to take the smaller value and put it into the original index location. So I'm going to move it left. Then I'm going to take the next value in the container or the array and move it to temp. So then I can put the index that's larger into the I+1. So you're doing a triangular move in that the larger value goes into the temp. Then we're going to move the value from the original index into the next element, and then the next element into the temp. So there are 3 steps in how we bubble sort. Now on the second part, you're going to have the main. So as we need to call in main, and we want to time this. Okay. So then you can do an import time it, and we want to use the time it in our main. And for the print here, what it's going to do is going to print begin to show each of the loop, right? As it checked each of the index against the next value. So it's going to check the value at the current index against the next value. So we're not going to print out the actual value just because as it sort, there's no point to printing out the value. You want to kind of see like how it goes through the process. So it could be any text here actually. So we just wanted to put begin so that way we can see the loop running. And what we're going to do is we are going to have 25 input. So in the print here, we simply going to print. Now, you do see some of the additional elements from Numba and NumPy that we talked about before, right? But when we use it as string like this, we don't need to implement the actual NumPy module or the package with it, okay? So what it's doing here is that we are doing the import inside the actual print function, okay? Unlike what you've seen before where you have an import statement at the top, and then you would then utilize NumPy and be able to create your array and so on. It's still going to be able to do that, but what we did was we pass it into the print statement, so therefore it needs to be string. Okay. So then with that, we would have the NumPy, and we want to use the arrange method, and we also going to do the D type, so that way it will handle decimal points or precision points. Okay. And as it shuffle, what we want to do is we want to create copy of the value. So we would add the copy function. And generally NumPy is going to help us randomize, right, the values. So when you run this, just like any random number, if it doesn't seed at the same point, then you won't have the same exact values every time. But it will also sort by comparison. Then we're going to also call the bubble sort method or function. And then with that, since we're calling there, we need to make sure that we put in the input. And as this is a C-based program, you have to have some kind of setup. Okay. So the setup is that it's going to look at the main, which is what we state here. And it's going to also bring in see itself as a module. So it's going to import in the function itself. So when you use it as a string like this, you have to state how you're going to set up with the main like this. Okay, so this is another approach that you can use, but you can also do it normally like how we would with the main and the call, like what we've seen in the assignment. So let me clear this. So when you run this program in IDE or in your Linux, right, as it loops through, you're going to see a bunch of begins, as we would use this to indicate that the input is being utilized. So it's sorting. as it loops through. And then it's going to give me the time that it took to sort my container. So here we see that when I ran this earlier, it actually took 8 seconds, but now I have 5.15. Okay, on the Linux side, right? Now we're going to take a look at the Linux side. Okay, so you have your virtual Linux machine running. The first step is to install Numba. I like to use pip3 because most Linux releases have version 2 and 3, so you can't discount that. So I want to make sure that I have it to the right directory, so I would use pip3. But if you only have one version, you just only need to run pip. So here, as I tested it earlier, you can see, so we would do a pip install Numba. Now, I also recommend doing sudo pip. The difference is that when you do a sudo pip install, you install for the entire system, where if you just do pip3 install, you only install for that particular user account. So if you prefer for that package to be used for other accounts or for the system, then you can do sudo. But if you want to only use it for the student account, you can just do pip3. And then if you do sudo, it's going to ask for the password. So we have CIS30E. Let me retype that. And once you authenticate with the password because this is a super user do so escalated privilege. And it's going to go through the installation. So I'm going to pull back up at the beginning. You're going to see something like this, right? It's going to pull the files, download, and then it's going to install. So I did it with both the pip and the sudo pip at the beginning. So this will take a few minutes. And I also recommend, I didn't write it into the lab step, is after you install software on Linux machines, you should always update. Okay. Even though it might have pulled the latest package, but in the case where other applications that was previously installed might utilize that package, it's always good that we update, or we would update before we install and after installation. So I recommend running the update, but you don't have to. Okay. So to run the update on Linux, you just do sudo apt-get update. Okay, so once you have your Numba package, we're gonna set our directory path. This is like setting environment variables on the Windows side. This allows you to link the package to the actual Python package, so we can run our files through Python. So it doesn't hurt to always do it. I always add it to the step because I assume that, sometime if you didn't do the last lab with this, you should add it just in case, right? So after that, what we can do is we can set our path, and if everything goes smoothly, right? If you don't have any typo or syntax, it just takes it. Otherwise, you're going to get error, right? So once you execute that command, it will just move you to the next pop-up or the command line or the terminal. Now, my advice for you when you add in this program, right? Check how you type it. So because I was playing around with it, and then when I modified some of the alignment, it didn't like that. So I have to fix that. So let me Let me pull up the program so you can see. Now, for those of you who like to use Nano with the line numbers, you can do Alt-Shift and the hashtag. That enables the line numbers so you can see which line in case you have error. Okay. So we can go to Nano, and that will be bubble sort.py. So when you start a new file, you can give it a name and its extension. And then once you're in it, you can just start typing. Make sure that we tab accordingly for the indentation because that's what Python requires. Okay. So we do Alt-Shift with the hashtag. It would show the line numbers in the front for you. And it doesn't always stay with the file. So whenever that you use it, you need to enable it so you can see. Okay. So here's my file, right? I have the function definition, the nested for loop for the index access. And then my condition statement to move or to compare, and then move. And then the reassignment when I do the move, the swap. And then my main, and then my time it, so I can use time it module. And I want to print out the time. Okay. So make sure everything is properly aligned and type as what it's shown. All right. So once we have that, right, we can press Control X to save, and then yes, and enter. So then after you have your code, then you need to execute it using Python. So we simply, let me reopen that bigger. Okay, we simply would do a Python 3 and then our file name, which is bubble sort.py. And just like what you've seen in the IDE, right? I showed you how that would be in IDE. We would run the begin. So earlier when I ran this, it gives me 8 point something seconds. Now you are at 6.9. So yours might be a little different, even though we're using the same virtual machine, because you might have a different processor, right? Now, if you want later on when we do parallel and concurrent program, we can enable multi-core, and we would see the improvement in that. Okay. So this program, we would implement NumPy and also Numba, right, to be able to get it running in a faster way. Now, we're not decorating anything, right, like what you've seen before when we talked about Numba. So a better way to also address this is if you look back at our notes. Okay, so let me go and find this real quick. You would see that when we talked about the assignment before, we talked about how Numba you would use the just in time. So in that case, you would then have to bring in Numba and then do the just in time, and use that decorator above your function definition. Okay. So we can further implement this and improve the program. Let me test that real quick. Hold on one second. Okay. So instead of doing that, we can do from number import JIT and see if we can decorate it. So okay, I'm not getting output after importing bubble sort. No error either. Did you have a print? So check your print statement and then make sure that your quotations are properly added. Okay, so it would likely be in this area that you're not getting. Okay. Any questions? So I would recommend checking this part. Okay. So if it's not outputting your values or your begin like this and a time value, then it's that. Okay. So when you use it like this, so in the original program, right, we didn't have it decorated. We didn't have these two lines. You saw that when I ran this earlier, it was about 5-6 seconds. But if I modified this and if I decorate this with the just in time, it shaves off quite a bit. Okay, so to fully integrate Numba, and we can do the same thing for the Linux side, right? So let me go back into here and I can do the same thing and check on the Linux side. So I can say from Numba import JIT, and then we can decorate it with JIT like this. And so because Numba uses just-in-time compiler, and then I'm going to go ahead and click Control X. And I'm going to do yes, but I'm going to modify this a little bit and give it a different name. Yes. So we can do Python 3 bubble sort. And I save it as number.py like this. Okay, so we see that it is 2.59 versus 6.59. So if you take this value divided by this value, you would get the speed up percentage. Okay, so let's check that. Get the calculator out. If I take let's say 2.59, so 2.59 roughly, or 2.5, that's 2.6. Let's round that off. Divided by 6.9. So you have about 38, 37% in the speed up by implementing Numba, right? So as you can see from the program that's screenshot on your lab, it's just a Python program for the bubble sort without the decorator, right? When we modified this with Numba, we simply just add in the import statement and then the decorator, which is what you've seen here. Okay. And then when we rerun that, we do see that it shaves out quite a bit. Now on the IDE, you're going to see that it's tremendously faster only because your IDE uses, you know, all your cores or the majority of your cores to run it, where on your virtual machine, you're only using one processor. So it does show a little slower in time in the Linux machine versus your regular IDE. Okay, question. So Joseph, were you able to fix and see any output? Okay, so, okay, all right. Let me know if you're having difficulty with it. Now, sometime it might be like a small delay, as you saw in my Linux program, right? If there's like a small delay before it begins because it needs to compile. Okay. So after you have your regular program, run it, get a time, and then add the decorator and Numba, and then run it again so you can see the difference in the time. Okay, I should edit the lab to really reflect that though. So you would write down the time for the pure Python and then add the decorator and rerun it, take a screen capture and see if it's faster. Okay. So when you add the decorator, definitely it should be faster, at least a little bit. Okay, roughly about 30–40%. So when you're recording that, you're sorting, right, 1,000 elements at 25 times. So you basically you're looping through, so your n is going to be 25 times in pure Python, and then you're going to record one with the second time that you use the decorator and your import statement or decorator for Numba. Okay. So from my end, I see that when I first ran it without Numba, this is the value for my time. And then when I added Numba, this is my value. So it would increase the speed by about 37%. Okay, so don't forget to answer the questions and add the screen capture. Now coming back here, right? We went from 1,000 elements 25 times. Now let's modify it to make it 100 times, because the more you run, the more concise your time would get. Okay, so when you test application like this, especially with libraries like Numba, we want to see it at a higher loop count. So that's pretty easy. So once you have your program created for number 10, you can go back into the program. So I would do bubble sort, and I added numba.py because I wanted to save different versions so I can show you. Okay, now I simply just put my arrow down to the last line, and I would change up my loop count. So, or the iteration for my loops, actually, that will be changed to 100. And then I would save, yes. And we can save it over that one. So change your number in the last line from 25 to 100 for number 10. And then we're gonna run Python 3 bubble. Actually, I just do the up arrow key like this. Okay, and as you saw, right, when we went from 25 to 100, it also shows faster. So I'm because why? There are data that's already cached. So there are, the processes is repeated. You do shave off quite a bit of time. So the more that you go with the number of times that you loop, you're going to see that your loop is going to be shorter, right? Your output, your time is going to be quicker. So here I would see 0.8 instead of 2 point something. Okay. And then I can also check on the IDE side to show you while you're working on that. So if we modify this to 100. Sorry. And then I'm just going to go ahead and save it over and I run it. Okay. There it is, right? 0.5. So 0.55 compared to 0.9, I believe the earlier time. So we can look at the speed up. So if I take 0.55 divided by, I think this was 0.95, right? So on the IDE side, my speed up is close to 60%. So it's about 0.57. Okay. So you do see tremendous improvement as you would have like a higher count for your loops. Okay, so we ran more times and for the same number of elements in the loops. Okay, then we would see that it's shaved off quite a bit of time. Any question? Okay, so when we compare that, right, is there a big difference? And you can look at the percentage and see. Okay, so when I went from this to this on the IDE, it improves about 60%. But when I went from pure Python to using it with Numba, right, it improves about 40%. So you do see a jump in the improvement for your time. Now, in a complex program or in web-based program, we want faster time, of course, for the response, especially when we're dealing with the server side. So you want to consider that little small shave of time, in the overall grand scheme of things, it does help quite a bit. Okay, any questions? Okay, so just to clarify, regular Python program, that was from the screenshot. For number 9, I add, right, the decorator and Numba import statement, rerun it, compare the time. For 10, we modify number variable in the statement and we change that from 25 to 100, keeping Numba, right? Then rerun it and see the improvement. Okay. Then for part B, we're going to work with PyPy. So this is another sort algorithm. And in selection sort, it actually take your container, right? and it's going to divide it into two parts. One side is going to be sorted, and we are sorting ascending, of course, low to high. And the other is unsorted. What we're going to do is we are going to move the smaller value, right, from the unsorted to the sorted side. So we need to append it. So if you think about the procedure in this, you started out with an unsorted container, array 1. Then what you can do is you can break that array into two parts. So the way that we can do this is we can transfer it into two subarrays, or, there are a couple approaches now, or we can find the middle point and divide it up. But it's probably best if we treat it as two separate containers. As we look at the value, right, from the unsorted, if it's smaller, we're going to move it to an array. We're going to append it to a sorted array. Okay? Which is as we move it to the left. So it would be like this. Your step 1, unsorted. 2 is the smallest value. We're going to append it to the container for the sorted array. Leave the rest behind. Then we're going to take the next value and we're going to compare it, right? The next smallest value, which is 4. Then 4 is after 2, so we're going to move it to after 2 into the sorted array. And we're going to keep doing that until we reach the end. So as we move in the sorted array from the unsorted array, your index value increases. Okay, so it's going to check the item. And in this one, it's also going to loop. Okay. And that means that it is dependent on the number of inputs you have. So it depends on how many elements you have in the container to sort. So on the outer loop, we're going to loop the n times, which is your number of input. On the inner loop, the I is going to be equal to 1. We're going to move from n minus 1. Okay. And then we're going to move left. So it's going to be n minus 2, n minus 3, and so on, all the way up to 1. Okay. So as we're moving left, we have to subtract. And that is for the selected values in the sort. Now, selection sort, when you look at example program online, there are several ways to address it. This is one approach. Okay. So, all right. Then for the procedure, you are going to download PyPy and you can extract it. Okay. And in the terminal, so you can manually download it and then unzip it. But in the terminal, we can just pull it directly. So if you're working with an IDE, you would visit the website, download you download the package that's compressed, and then you need to decompress it. Okay. If you're working with Linux terminal or command line, you can just pull it directly. And this is the command for Linux side. So you have to do a snap install. And what that does is it's going to decompress as it downloads and install it for me all at once. If you just use sudo, if you're using the pip portion, it's only, so on the compressed file like this, normally we would do a curl command, pull the actual compressed, package, and then decompress it with the tar. Okay. So if you're using snap command, what you can do is you can decompress and install after download all at once. And that's what I really love about Linux, is that like they just censor down a lot of the extra steps, especially, if you're using terminal. Okay. go back in. CLS, I forgot. All right. What we're gonna do is gonna do a sudo snap install py3 classic. Then input our password. So I already have it installed, so it won't let me install again, but you would use this command to install the PyPy classic. Now on the Tawny side, right, when you search for this or on your IDE, if you put in PyPy, it's gonna give you different package and sub-package or something related to it, right? If you pull this. Now some IDEs support PyPy, some don't. In this case, right, what I would need to do is I would need to go to the actual website and then download it. Okay, because I can try to click install here. You're gonna see that it's gonna tell me error, right? Cannot find a version to satisfy that my IDE would need. So I would then need to download the compress and decompress it, make sure that it is in the site package, and so on. But read the documentation, they walk you through how to do that. All right. After we put PyPy in our system, okay, you can go to the PyPy folder, then you can open the bin. So, and I can do ls in terminal like this. And when I open up the terminal, now when you install PyPy, it will tell you where PyPy is installed. Okay. Trying to view will access the current directory inside bin, inside PyPy directory. Then you create the Python file. Let me see. Okay, to navigate, sorry, let's go back here. I'm not seeing that on the LS side. Let's see, instead of pictures moving under the bill. Let's see where it places it real quick. Pypy. That's where I had it wiped off. Okay. Hold on 1 second. Let me. See on the new package where they placed this, because before it dropped it into the directory. Download and install. Just-in-time compiler versions. wonder if it's not in here. Snap. I'm not seeing it in here either. Hmm. Okay, let me try it with just this, and so I don't think you need to put it into the directory. Okay, might have changed the location. So, all right, so we can write our code. We're gonna nano selection sort dot Python. Oh, I put insertion sort. Sorry. Let me rename that. Control X this. We're gonna name this as selection sort. Yes. Okay. Three selection sort. Okay, we probably have to download it. So let's see. So you would need to download it because I think even if you do the snap, it won't pull it and put the directory for you. So open your Firefox, right? And then you can go through to the website like this. And then we're going to click download and install. Sorry, it's a little slow. So for my Linux version, OS and Python 3.9 and above. So I'm just going to do this. So click the version for your Linux. I'm going to try it this way and see if it's going to put the actual module folder inside my home directory. Okay, so once you click download, right, you can just simply extract it, but what will happen is it's going to extract it to the downloads. Okay, so here's my download. What I'll do is I'm going to go ahead and copy or cut this. and put it into home where all my programs are. Okay. And then you can do the tar, you can just say extract here. So that will put it right here. All right, so so what you need to do is go to the browser, right? We search for PyPy, download, and then you're gonna select 3.9 for Linux, this one, click download. Once you download that, okay, put it onto your home directory and extract it. So right click, choose extract. Once you have it extracted, it would have a PyPy 3-X folder like this. Okay, so we need to move into this folder, into this bin folder, and we're going to put our code here. Okay, because it needs to see these modules or these files to be able to run your program. Otherwise, right, you saw that you cannot run the PyPy extension. Okay. So what I'm going to do is, let me see. I'm going to copy this path. And then I'm going to come back to the terminal. So I'm already in home right here, right? I'm just going to go ahead and do a CD. And I'm going to paste my path. So you just need to make sure that it's like exactly like this folder name. So now I'm inside that folder and I'm going to do a CD bin. Okay. And then what I'll do is I need to, and you can do this on the graphical user interface. You can use your text editor, write the file, and then put it there, right? So let me, I have my processes out of order here. So let me come back. I'm going to go ahead and go and get my file. Okay. And I don't know why it didn't save that. Okay, next. Yes, enter. Okay. So I have my file corrected. Then I'm going to go ahead and it's probably easier for you to do it this way because you're going to get confused. In your home, once you have your file, your nano file, or you can nano into it after the path is selected. So mine was selection sort or insertion sort. You simply copy this. And then you're going to go into your PyPy folder, your bin folder, and paste it in here. Okay, so if you wrote your file in the home directory, okay, you can just cut it and put it in there. Now, if you didn't do that, you can go to your terminal. Okay, you're going to do a CD. And then the PyPy folder, access it. So we open up the folder. And then you're going to do a CD bin to access its subfolder. And then at this point, you're going to do a nano, your sort.py. Where did I put this here? Selection sort. And then I can write my program and save it there. Okay. All right. Any question? Control X to save. Yes. Enter. Okay. So let's talk about the program for selection sort. And name it insertion sort. I don't know why I was thinking about insertion sort. So this traditionally, it is a Python program. You have a function definition. In the parameter for this, we are going to use input list. And we are going to nest in a for loop. In this for loop, as we are moving from the index to its left, we are going, remember that we start with the sort, right? And then we're gonna go I-1, so that's gonna be J. So your J is gonna be the index left. And your next element variable here is gonna store the value for each of the index in the list. We have a while statement. It's gonna access J, which is your value of the left of the index. It's gonna compare that to the next element. If it is greater than your next element, and if it is greater than 0 or equal to 0, then it's gonna add it to the location or append it to the list of the index right. Okay. And it's going to update. Okay. Then it's going to take what's to its left and then it's going to add it to the current index. So this is how, very similar to the other one, but instead of moving right, we're actually moving left on this one. As the left side is going to be the sequential order for our sort. And on the right side, it's just going to be unsorted. Okay. And these are the value. We have 19, 2, 31, 45, and so on. So after we define the function, we simply call it, right? And we want to print it. So if I run this, I don't think it's going to go up. It does give me just the, see how, because it's not using, on this, it's giving me 19 to 31. So that's just the original list. Okay. All right. But what we want to do is later on in the program, you want to decorate it with your JIT and use the Numba. Okay, so let's come back to the Linux side. Once you already have your file created, right? To build this properly with PyPy, we want to use the extension. So you're going to use /pypy3 selection sort.py. Okay. Okay. So it's giving me this, right? I'm not getting this sort build. Let me see why it's doing it. Oh, it's just printing the list. Maybe indentation is off. Let me put it on top and see what it does here. Yeah. So if we define it like this, yeah, it's only going to print the list. Yeah, it's like that. Okay. Let me troubleshoot this. I think that there's some issues with this program. I didn't catch it before, or I might have modified it, but ultimately we should get a sorted list. Okay. Now, because it's simply printing out the same thing as this list, it's not operating the function call here, insertion short with the list. This is our list. Yeah, it's not outputting that, but let's see if it cranks out faster time with just doing that. Okay. So if I go and I modified this and I add from Numba import JIT. Oh, we didn't use Numba. We use it Pypy. So if we run this, it shows you we need to time it, right? So you need to add the other part. Okay, so make sure that we add the print option here and then put in your value. So I think I screenshot a different program than the one I have displayed, but so your time it and then your nums. And then once you do that, you're gonna have it do 25 times, just like the other one. Okay. Let me fix that in here. So range imaging. No. Yeah, I'm showing you the insertion sort instead of the selection sort. X. Okay, let's retake this part. Give me 1 second. Let me speed up the process real quick, okay? Selection sort. Yeah, I copied the wrong file over. Okay, just a few more seconds. ATC. Okay, so that was the insertion. And then okay, so let me try that again for you. Okay, so for the selection sort, Control X, this. Let's share screen again. Okay, so for the selection sort, we have the loop. It's gonna look at the low value range. Then it's gonna compare if the index value is less, right, than the lowest value in the index, then it's gonna update J. So that allows us to compare before we swap. Then we're gonna do the swap. Okay, so the index value, the lowest index value. So that would make us swap through If it is low, we move it to the left. If it's high, we move it to the right. Then in the second part, this is going to be for our print. We're going to test it 25 times, right? Same with the other one. And this is pure Python. So when you run this should work. So in each of the swap, it actually shows you what it's doing. Okay. And then at the end, you should be able to get the time. Okay. That's if you run it on the IDE. On the Linux side, make sure that you are downloaded PyPy, decompress it, or unzip it. Then you are going to navigate inside that folder to make your file. And we saw how to do the CD and under bin. Once you do that, then you create your file. Okay, just like what we've seen here. Then you are going to save and run. Okay. So when we use it with PyPy, you see that it is like this. Okay. 0.002 or 3, close to it. Now, if we just run it like a regular Python file, we can say Python 3 selection sort.py. Right? We have 0.01225. Okay. Pretty close, I think, with the PyPy. You do see that it is, right? It's 0.022 compared to 0.01. So very, very close for the selection sort. So how do you test it with Python only? You use Python 3 command. How do you test it with PyPy? Just make sure that you in the PyPy directory, you would test it with the .pypy3 command. Okay, which allows you to use the extension package. So when you answer 18, 19, and 20, and so on, so after we execute it with PyPy, take a screenshot, it shows the time recorded. For number 19, we can modify it. So we come back here, we can nano back into it again, right? And then we go down to the last line and we change this value to 100. Control C. And then I save. Yes. I'm gonna call this up. And then save. Yes. So now if I wanted to execute the selection sort when I change up the value, then I just use the PyPy command again. Okay. So when we increase that to 100 on my virtual machine, it shows that it is actually higher, right? You get a 0.14 compared to less with 25. Okay. So you can take a look, modify your code to 100 times and then check it. Then run it with your regular Python. So now let's try it with regular Python. So Python 3, right? And selection sort up. Okay. And so Python is pretty consistent. It is pretty close to what it was before. Right? Slightly higher, but not too much. Very, very close. Okay. All right. So you can compare the difference there. And then I didn't put in the insertion sort for you, but These are just the two comparison programs that you would see. Okay. So the important takeaway with PyPy is that you need to bring in the tool or the package, decompress it, and as you decompress it, even if you install it, I think it puts it in the site packages a little different. So you have to go to the website, download it, decompress it, and then I would put it into the home or a folder where you want to be able to execute it. And then inside that, right, we want to navigate to the uncompressed folder, okay, and then go into the bin and make sure that we write our code in there. Otherwise, you gotta set, you have to set your environmental variable path, and so on. You can install it regularly, like what we've done with the other ones. You just gotta set your home path, making sure that it sees it, so that way you can run it. But when I tested this previously, in the other times, this is the quickest way that you can do without, causing any confusion. So make sure that you just follow the steps, and I put that here, okay? And then create your file, and then test it with PyPy and with Python. Okay, so you can see the speed up or even slow down sometimes, right? Doesn't always guarantee speed up. So any question regarding the lab or any challenges you have? Okay. I thought I wrote an insertion one, but I guess that wasn't corrected. So I think that it was having issue here. But you just need to do the bubble and the selection sort, okay? And these would run, so when you run it in the IDE like this, right, you're not really using PyPy, you're just using Python. So to test PyPy, we got to make sure that we run it with PyPy. So as you see that my IDE didn't like the PyPy installation, so I'm only able to operate it with the Python in my IDE. But on the Linux side, you can, as long as you put it into the PyPy subdirectory, which is bin, and then write your code and then execute it there, because it's going to need this file to run, PyPy3. Okay. Any question? Okay. So through this lab, we experimented with our Numba, right, using just-in-time compiler. And we tested against regular Python. Okay. And that was implemented with the bubble sort. And then you have PyPy for the second exercise using selection sort. And with that, we have to download, extract, right, move it into our home directory, access its subfolder, which is bin, put our code there, and be able to execute it. And then we would compare using PyPy 3 compared to regular Python 3. Okay, and you would see the difference in the time. And that's how we're able to test pure Python against Python program that's using other libraries or packages. And then when we're done, we would just go and shut down. So we can do shut down now, and your Linux will power down. Okay. Any questions? All right. We do have about 30 minutes still, so I'll stick around for questions. I'm going to go ahead and stop recording.